Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? Happy Easter. Sunday fun day. Yeah, what's up, Raven? Frohe Ostem? What's that? What's Frohe Ostem? Is that a different language for like Happy Easter? Oh, let me start this on. Sorry, let me start this on. Start us on Discord. There we go. What is Frohe Ostem? That sounds like Latin or something. Yeah? What are you doing, Dr. Gold? We are here. We're helping you guys out. Math, science.
Good job.
I was out pretty late last night. I was DJing a party till like, it was a housewarming party that went to like 7 a.m. So I woke up only a couple hours ago. Let's see. Frohe Ostem. How are you doing, Raven? What's going on? Oh, it's the German for Happy Easter, is Frohe Ostern. That's fun. Yeah, what's the big thing people do for Easter? Like painting eggs and stuff? Or, like an Easter egg hunt. My parents used to always do that. Like, they would give us all baskets and we'd have to go, around the backyard and go find, like, Easter eggs with, like, chocolate and stuff in them. That was always fun. But no Easter egg hunt today, for me. I'm chilling. Let's see. News. We had a really fun game on Friday. Thanks everyone that came by for marbles on stream. That's always fun. And then I do have a collaboration we might be doing in the future. What's up, Nick?
Good job.
It's your birthday? What the hell?
Oh, it is my birthday. Yeah, thank you, dude.
No. Happy birthday, man.
Appreciate you, dude. Thanks, man. Yeah, what did I do? What's up?
What are you gonna do?
What am I gonna do? I had a bunch of people. I saw a bunch of people. Oh, thanks, Dramino. It just doesn't mention it's his birthday. Thank you. I don't know. As I get older, the years just mark closer to the end, I guess. But thank you.
Unfortunately.
Yes. Hey, Gladiator, what's going on? Yeah, no, I had a bunch of friends I saw last night at a housewarming party, and I was DJing. That was fun. And then,
Nice.
I don't know. Today I'm going to another birthday party. Someone else is having a birthday party. I was like, oh, I'll go to their party at least.
I haven't seen you in years.
What's yeah? I haven't seen you. I haven't seen you since Friday, dude. What? Zach. What is it? Freaky Zach, right? Or no?
Freaky Zach, what the hell?
He had a funny.
Yeah, you gotta.
Yeah.
Hey,
How is this so Easter moves around actually. Yeah, so my birthday has been on Easter a couple times already. My mom's birthday is also a week after mine. I think her birthday is the 11th. And so sometimes Easter falls on her birthday. Because Easter's always on Sunday. But as we know, the days move around, right? So my birthday's not always on Sunday. So sometimes my birthday falls on Easter as well. What do people buy as birthday presents these days? Someone got me a nice watch. It was kind of fun. My friend Alex got me like a gold Casio. I don't know. At my age, it's kind of you either go out to dinner or someone buys you a bottle of scotch or something. Yeah,
Some bourbon.
yeah, some bourbon or something. Someone gets you a drink. That's kind of like what that's what birthdays are these days. Yes, I remember when I was younger, I used to always think about, oh man, like what video game can I get, or like can I convince my parents to buy me a graphics card or something. Or
Yeah, we
shoes.
need to get gold a video game, bro.
Yeah.
Or a
Yeah.
toy.
I always loved like I wanted like certain basketball shoes I would like really ask for. And then
Yeah.
I used to throw massive birthday parties in high school because honestly they were money making like activities. Like I love throwing parties, I love having friends over. But also when you have everyone would give you like a $20 gift card or something. So if you invited like 50 people over, dude, you'd make like $1,000 in just like random gift cards. It was actually it was kind of cool. You have a Casio? Yeah, I love Casios. This is my like day-to-day Casio, and then my friend here. Let me see it. Amazon Casio. This is the one my friend got me this one for my birthday.
Yeah.
I like Casios. They're fun. They're fun watches. Yeah, I'm a big fan of Casios. I have a couple Casios actually. What Casio do you have, Raven? Yeah, if I type in Casio, let's see on my Google Photos. This is like my current collection of Casios.
Holy,
I
what
have-
the fuck?
Yeah, I have
Dang.
I have the calculator one.
Who got a calculator on there? What the?
The calculator one's fun. It actually, you can do a lot of really fun stuff on this one. It's super annoying to use this keypad, but you can, and you can do even like currency conversion.
What?
Like it's like simple math stuff, but yeah, you can do math on this one. This one it's called like a data bank, so like you could put people's phone numbers in there. I remember I would put like my girlfriend at the time and like my mom and my dad, just because like sometimes like your phone would die and you're like, fuck, like what's their phone number? Like how do I contact someone?
Damn.
Yeah. Congrats, Raven, on getting the physics teacher job.
Oh,
I forgot.
snap.
Yeah, nice. No, that's a fun job. I mean, I'm technically a physics teacher. I have to go into UCLA and teach a class on the 16th, and then I
Shit,
will be.
again.
Yeah. I'm just substituting in for like one class, but then over the summer I'll be teaching an online UCLA physics course, and we'll be doing it right here on Twitch. So you guys want to?
Damn, together? What the hell?
Yeah, I won't include the Twitch chat in on the class though,
Oh,
because
damn.
you guys would start like, yeah. But you can still watch.
Yeah.
You can watch me teach physics on Twitch. Yeah.
We're gonna get gold banned. Holy shit, yo.
Yeah, don't do it. Yeah. You have the square one with Roman numerals and a leather band. Nice. Yeah. What? Yeah. Holy fuck! I can't. Are you okay, JC, dude?
Where did I get this crown? I'm so confused.
What
When
physics
did I-
course? So it'll be first year E&M. It actually includes a little bit of waves as well. And I think no optics. Optics is
Am
physics
I gonna
1C.
be killing next? Oh, yeah, that's great.
Here we go. Physics 1B at UCLA. That's the class I teach. Let me see. Here we go. Physics 1B. So yeah, there we go. It's fluid mechanics, oscillations, waves, and sound, electrical charge, potential, capacitors, and dielectrics. Yeah, so there's circuits and stuff. Actually, yeah, I remember. I don't actually like how UCLA does this, but there's no magnetics. It's all electrostatics. Usually, like E&M is like, you know, the electric stuff and the magnetic stuff is all in like one course, but I think they put the magnetic stuff in like 1C.
I don't know. I'm nervous to play Kilo in this game.
You nervous to play what, Zach? What's up?
I'm playing this game on Roblox called Bite by Night. It's pretty new.
Bite by Night. Dude, my name's not here on the this website's called Bruinwalk, and they use it for like rating professors. This is too funny. I guess I haven't taught it enough times for people to like start writing public reviews about me. I have my private reviews that they give in the class. Those are kind of fun. Thanks, Breasticles. Appreciate it, dude. Anyways, okay. So, yeah. That'll be over the summer if you guys want to go. Who's the worst? There are some pretty bad teachers.
Oh no.
Yeah, don't worry. I'm not the worst.
Yeah.
I get pretty good reviews actually. If you ever look at my I think I have them on my LinkedIn. Here, let me go find my LinkedIn.
Go gold.
What's up, dog?
Tomorrow is my first 12-hour shift off OJT.
What's OJT mean?
On the job training.
Oh, nice.
I'm fucking terrified, bro.
You'll be fine, dude. I know you're gonna be great.
I
What is
hope.
Raven says you could complain about how having reviews when your students find out about your Twitch. Yeah. So these are my I get pretty good reviews. You ever want to like read? My LinkedIn has the link to this, but this is all the comments people have said about my class. Dr. G does an amazing job and really shows he cares. Whatever. Yeah. Oh yeah. Great. I like the teacher.
Dr. G.
Yeah, I have him call me Dr. G, not Dr. Gold, because then they would be a little confused. But like my first name technically is Giovanni, so like it's okay to be Dr. G. Yeah. Okay. That being said, it looks like we already have some questions for today. I'm gonna be streaming a short amount of time because I have to go to another person's birthday dinner thing later. I'm here with you guys. Terrence Tao, Terrence Tao's at UCLA. Yeah, T Tao, dude. I've had some friends who've had him as like a PhD advisor. Who's been spamming these A-level questions? I don't know. We're gonna go do it. But okay, cool. Let's start with the stream. Help you guys out, and here we go. All right, welcome everyone to Office Hours. This is Actual Education. My name is Dr. Gold. Streaming to help you with math, homework, science homework. All sorts of fun stuff. We got 3 questions already in here. Let's go live on TikTok, TikTok, Twitch, all fun stuff. You didn't miss the birthday stream, yeah. I'm glad I'm streaming. Again, I went to bed at 7 a.m. last night. So but I told myself, I said, okay, but you have to. You said you were gonna teach today on Sunday, so you have to go do that.
That's great.
I'm a man of my word, at least. Here, let me, and then where is? Let's start the stream. Go live. Yep. There we go. Okay, cool. All right, let's see what's on the queue so far. What have you guys been giving me recently? Okay, we have 4 questions in the queue already. Cool, fun. Ace submitted 402 minutes ago. Ace. It's too funny. You're not supposed to do this, but okay, I'll allow it for now. Here, we'll start doing this one.
Bro.
Yeah, we'll do this one.
He's a cheater.
Yeah, we'll see.
Gambling.
We'll see if he still gets picked
Yo,
though.
what
I don't
if
know.
He loses anyway.
What if he loses, dude? No, he got it.
Come on.
Disqualified.
Okay, all right. Now it's a little bit more even. Yeah, that would have been too funny. Okay, let's see. Ooh, looks like chemistry. JC, your favorite dude. Your favorite dude. All right, let's see. Yeah, JC loves it. Yeah, sexy. I think we're doing. Is this MCAT MC Delta T? Mostly converting calories to joules. Yeah, I guess so. Okay. Okay. So it says, in an experiment, a student was given a 10-gram sample of an unknown cold pack agreement along with the following data. Okay, cool. If you want to ask me, what's the important question you want to ask me? Nick?
About my job and if I should quit or not.
No, don't quit your job, dude. What? Dude,
It's
definitely don't
like,
quit your job. It's hard to get a job these days.
Should I go to college or drop like a $100,000 annual salary?
I would work your job for a little bit and then, then decide whether you want to go back to school. You can always go back to school whenever, dude. I mean, and you're young too. But I would definitely get some work experience like at your job first, and as long as you don't absolutely hate yourself, like it's all good.
I mean, it's fucking scary, bro. Scary.
I know. Yeah. Nick works at a prison. He's a jail warden type thing. It's kind of fun.
A CEO.
He works with some scary people. Yeah. He's a corrections officer. There we go. But you had to like take a test and everything for that, and we helped you out like preparing for that test.
Yep.
So you should work there at least a year, I would say.
At least. I know.
At least a year. And then decide afterwards if you want to like continue being a corrections officer or if you want to start putting the time towards, again, going back to school and like learning more skills. Yeah. Don't quit your job. You just started.
Thank you. Well, because I'm already having fucking panic attacks and shit.
I know. And especially like your generation is gone through a lot with like COVID and things. So I get that there's kind of this aversion to fear, like in danger, right?
Yeah.
You just got to keep pushing through it. You'll get there. I'm happy you're out of your basement and like you have a job. That's dude, so many kids your age don't leave the house. So I'm glad you've left the house. Keep leaving the house. Yeah, you're good.
Yes, sir.
All right, let's see. 10 grams of sample in a styrofoam container containing 100 mils of water at 25 degrees. What's up, Jeremiah? The temperature decreased. Oh, okay. I guess that's why it's a cold pack. What was the starting temperature? Oh, starting was 25. Okay. Identify the unknown substance by finding its enthalpy of solution from the experimental data and then comparing delta H. Okay, great. Okay, cool. So I think we want to do, right? I think it's Q is equal to MC delta T. MCAT is what they call it sometimes. So this is going to be, and the key thing here is that like Q in is equal to like negative like Q out. So the heat that is absorbed by the water is the negative of the heat that's given off by the substance. In this case, the water is actually decreasing in temperature. So the substance is absorbing heat, absorbing Q, and Q is leaving the water. That's why the water like goes down in temp. What do you mean old times? They don't call it MCAT anymore? I don't know. Maybe they... What's up, Jack? Good to see you, dude. The old times. So here, let's do it for the water, right? If we do for the water, then we'll understand what it must have been for the material. So the mass of water. This is the cool thing about water, is that 1 milliliter is equal to 1 centimeter cubed, which is also equal to 1 gram. Super fun. So here we can, and I think I see joules per gram, so let's do it that way. So for mass of water, that's going to be 100 ml, so that's going to be 100 grams. C for water is 4.186, and I believe that's joules per gram. That's called the specific heat of water. What's up, racist? And then the change in temperature. So it's going from 25 to 18.38. So we're going to do this 25. Technically, you're supposed to do this. You do 18.38 minus 25. It's final minus initial. Yeah, 4.186, right, Jeff? Yeah, cool. Appreciate it. Well, I think it's joules per gram, and then I think it's like degrees. I think it's degrees. I think there's technically like a this. Right? It takes 4.186 joules to raise the temperature of 1 gram of water 1 degree Celsius. Yes, per degree C, yeah. This rules. What's up, Blank? Okay, cool. So, let's go find our calculator. We can start doing some math. Yes, I am doing physics, yeah. If you want to submit a physics question, you're more than welcome to. The website there, actualofficehours.com. That's how people submit their screenshots, and then we do a little gambling to see whose question we're gonna do. But here, let's do this. This is Chem. So we're gonna do 100 times 4.186 times let's see, let's do 25 minus 18.38, and that gets me 2771. Cool. So that's how many joules were transferred from the water to whatever this material was. So okay, so Q is equal to 2771, and that's joules. And then what we want to know is that also needs to equal to the specific heat, I guess, of the delta H of whatever our material is, which is 10 grams. So I think that needs to be equal to 10 grams times delta H, maybe. Yeah, because this is heat of solution, enthalpy of solution. Okay, so if you move this over, right, you get that delta H is equal to 277.1 joules per gram. And let's see, which one is that? Probably this one. Right, it looks pretty similar. Yeah. So that tells us that the material must be ammonium chloride and H4Cl. Only fake chemists use joules per gram. Definition of a calorie. Yeah. Okay, cool. There we go. So yeah, that's it. Yeah, I mean, this was like kind of like thermochem, I guess, technically. All right, let's mark that one as done. What's up, Flask? Why is it logging in again? I don't even log in. Dun, dun, dun. Okay, cool. All right, got it. All right, so that was Aces. Yes, you can totally send a heat transfer question. So if you ever want to submit a question, the way to do that is to use that website down there, actualofficehours.com. Oh, I realize our Twitch chat's not showing on TikTok now. I gotta. TikTok gets mad at me sometimes. I gotta go fix that. This was Aces. Cool. Yeah, Sensation. What's up, dude? Come on up. Have I not get? Let me give you perms. I should give you perms so you can just like do that yourself.
Not till you've heard what I've got to say.
Oh no, what's he gonna say? Don't get me banned on Twitch. Don't get me banned on Twitch.
Holy shit.
Just start screaming the N-word down the fucking pipe.
Don't do it. Don't do it.
No, that's my job. Don't steal my job.
Don't do it. Don't do it. It's like I have the power to like end this channel.
As someone who currently has Rust up in the background, actually, it's my job.
It's your job.
As an avid Rust player, if anyone, it would be me.
Bro.
Is the Rust voice chat like basically like Xbox Live from like 2008?
Oh, it's worse. It's worse.
It's worse. It's way worse.
The other day during one of your streams, it was wipe day, and I was in safe zone, and I was amazed because I only heard the N-word maybe 4 or 5 times.
Okay.
Only.
Only.
Yeah. I was amazed. It was Rusty Moose too.
Wow. Connect fork. What is even going on in Rust? I don't know, dude. Rust is probably like an experiment for humanity.
It's something.
You start out naked, right? Like you start out with like no fucking clothes.
You spawn on a beach naked with a rock and a torch, and then you go and then you like build bases, and then you get like AKs, and you build like a big base, and you like try to defend
RPGs
it.
and stuff.
And then there's like safe zones that you go in, but the safe zones just kind of become like a lot of young children screaming the N-word at each other.
Oh dear. Oh dear. Bless you, child.
So I heard Minecraft on steroids. Interesting.
No, it's like Roblox.
Yeah, pretty much. Yeah.
Roblox has like cotton picker simulator on it or something, right?
I'm weak.
What? Like,
I'm weak.
chill, dude. What?
Oh no.
All right, here. Let's go choose a winner. Who's gonna win the spin? Who's gonna win the spin? No, it's actually pretty even.
Gambling.
True chat units only. Haunted. You win, Haunted. What do you got for me, Haunted? You got something scary? Uh-oh.
Aw, dang it.
Dude, what's going on here? Excuse me, what the fuck is this? What's up, Haunted? Hi. Yeah, I don't know what this question is, but here we'll read it. We'll read it. Okay. DRP. Just go over it. Okay, let's just go over it. Yeah, cool. I'm down to go over it. Yeah, let's just see. All right. So consider 5x. I guess is a function that I don't know what this means. Infinity. And it's a set. I think this is a set. Democratic Republic of the Congo. No, that's DRC. Infimum. Okay, cool. Infimum. Z, I believe, are integers, right? You say the set of all integers where x is a real number, the distance from some real number x and some natural number.
Yeah, it's saying there's a set that's the absolute value of x minus n, and the infimum is the greatest lower bound of that set.
Right, yeah. I've heard this. This is kind of like a real analysis thing sometimes.
Yeah, it looks like analysis.
Yeah, okay. Definition, so if f maps reals to reals, it's a Lipschitz function. If for all x and y, f of x minus... Dude, this looks like epsilon delta almost, right? Yeah? We're saying, like, the difference in the outputs is less than or equal to the difference of the inputs, where L is a Lipschitz constant. WTS, want to show, I assume. 5x is continuous by the definition of this. Okay, cool. Let R to R and define what we already said. By definition, for all x, y. Yep. Oh, and n is some natural number, I guess. N is a natural number. Yeah, okay. Claim. Can we go over some set theory? I don't know too much of set theory. My top end for math is kind of like differential equations or like maybe complex analysis. But so I will use this time to like maybe plug one of our friends real quick. So if you go to the same website where people are submitting questions, actualofficehours.com, click on the streaming schedule here. You'll see there are some other streamers. I'm not the only person that does stuff. So Zach is another great streamer, and he knows a lot about set theory. And so this is Zach's streams are in purple here. He has some math homework help. What is Penn Center doing? Let's destroy AI. Shooty. What is this event, Penn?
Sounds American.
Sounds American. He's from Canada though.
A little too American.
Yeah. But anyways, yeah. So I highly recommend go say hi to one of Zach's streams. Zach. Here I'll share him out. E to the 2i pi. Yeah. He's a great streamer who knows a lot more about set theory than I do. I'm just gonna read through this. We'll just see. Gen AI, it's a fascist project. What? AI is a fascist project. What? I love Penn Center's like you're prompting with Hitler. What?
That's crazy.
Okay, all right. K is a natural such that phi x minus phi y is equal to that, is equal to this, is less than this. Letting K be in the set of natural numbers where n2 becomes as close to y as n1 is to x. Setting K equals n2 plus n1. Okay. As n ranges over z for any fixed n, also ranges. Cool. I guess this is a proof. It's funny, these types of things I'm like, yeah, cool, 2 plus 2 is equal to 4, great. But I get that there's some rigor into how you set this up, and how you set the the proof. But okay, cool. Nice. It looks great. I'll put it in our Discord, and I'll tag like Zach if Zach or anyone else who's watching. If you guys know Set Theory, and you want to make some comments on it, please do so.
Narosky probably does.
Narosky probably does. Yeah, Narosky knows a decent amount. This took you 1.5 months. This piece of paper here took you a month and a half. Excuse me, what? Oh, to learn. Okay, never mind. Okay. Yeah, I will learn it at some point. I think Zach is gonna do like a real analysis class over the summer. We have this agreement where like I'm gonna teach Zach E&M, and he's gonna teach me real analysis. But cool. All right. Cool question, Haunted. I always, even if I don't understand that type of stuff, it's fun to see it and get exposed to it.
How's your Spanish, by the way?
Mi español es más o menos bueno. Yo no lo sé. It's better when I have like practice, and my neighbor doesn't speak English, so whenever they come over like wasted, like my Spanish starts getting better.
All right then. So, you see that GIF that I just posted with? I forgot which footballer that is.
Oh, with Messi when the Jews did this. Yeah.
Read his lips.
I can't. Like, what's this? Wait, isn't Messi Portuguese though? This is Ronaldo. Isn't Ronaldo Portuguese?
No, Ronaldo's Spanish, but he's speaking Spanish there.
What is he saying?
Injusticia.
Oh, injustice. Injustice. Injusticia.
Injusticia. The Jews did this.
Injusticia. Well, I will say that it's like Spanish, and Mexican Spanish are two completely different languages. Honestly, sometimes. Because yeah, they do the with all their pronunciations, whereas like Mexican Spanish over here is a lot different.
It's another beast. I got like a lot of my team that I play Rust with are Spanish, but they're all from like different parts of South America.
Sure.
And they joke that even like the ones like native Spanish speakers, they'll talk to people from like a different part of South America, and they're like, I don't understand what the hell they're saying sometimes. They're like talking like fast as hell, don't understand any of it, like,
and there's like some slang
completely
and, like,
out of it.
I don't know, there's some interesting with like pronunciation stuff, like all the V's become like B's and stuff, and then I don't know, all the L's become Asia, like instead of Medellin looks like it should be like Medellin, right, because it's double L's, but they make double L's like je, so it's like Asia, Medellin. It's very interesting.
Yeah, it is. I don't speak any of it, so to me, I tune it out. I only recognize like way and Oliverga.
Vamos way.
Something mamas. I don't remember.
No mamas way. No mamas way is like no way.
Stuff like that.
Yeah. You'll pick it up. I mean, the only reason I learned it, I had like a Colombian girlfriend who didn't speak any English, and so the brain will always find a way to learn things if it has to, like if there's like a reason. I think it's great for you guys to like learn languages in like high school and stuff, but I also took Spanish in high school, but I don't remember any of it. It wasn't until like in my late 20s that, again, I had someone who didn't speak English, and if I wanted to communicate with them, I had to learn Spanish. That's when it really started to click for me, and I was like, okay, now I have a reason to learn this. Yeah. How did you get a girlfriend? I don't know. I just, it's Colombia. You just go around. As long as you have a passport, like you're okay. Yeah, Quebecois is another fun one. Like, yeah, Quebecois. I love Quebecois. It's like a dirty French. It's kind of fun. All right. Took her voice. Oh, what? The witch took her voice. Okay. Here, let's see who's gonna be the next question of the day.
Let's go gambling.
It's either gonna be Gladiator or Breasticles. Looks like it's gonna be Breasticles. Wow, dude. Yeah, you're not shadow banned today, dude.
Yeah, I was hoping.
Wait, this is your question? Y is equal to?
Yeah.
Oh, is this like is this an
equation?
Is this an infinite differential equation?
Yes.
What's up, random dude on Twitch? Dirt or no dirt? Yes, dude. The dirt questions, dude. I had no clue how to solve those, by the way. Okay. So this like just keeps going up in derivatives, I guess, right?
Yeah, in essence.
Fascinating. All right, so I mean my gut instinct whenever I just see like a bunch of derivatives like this is to assume that like y is of this form, like e to the ax, and so like y prime is equal to a e to the ax, and you know y double prime is equal to a squared e to the ax. So if I were to substitute that in here, I would get like 1 is equal to a plus a squared plus a to the third plus dot 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 dot. Is that a way to solve it, or am I like completely on the wrong path?
Yeah, kind of. I've seen a I've seen a solution to this like that. I just don't remember how. You can
I feel
do
like you
very
could come up with a
similarly
series. You just need a series to converge to 1.
Yeah, that's
right?
why I submitted this one, because this one like is a kind of a cool problem when you do it
Yeah.
this way. So if you take out your derivative operators, right? You say like, you know, ddx is equal to just d as
Okay.
an operator. You'll get your d plus d squared plus d cubed plus d to the fourth, etc. for that whole
Mhm.
series
Mm-hmm.
operating on y.
Okay. So you're gonna say like d, or let's just say ddx is equal to d. So you're gonna get d plus d squared plus d to the third plus dot 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 dot, and this is all acting on y, and then this has to equal to y as well. And can you just
Yeah,
divide both
and-
sides by y? So it's just 1.
No.
Or no, right?
Yeah, because the derivative is acting on y as an operator. It's not like multiplying.
Okay.
But what you can do is factor out I believe a d, and then turn that into an infinite series. Or not an
Factor out
infinite
this d?
series. Factor out a d from there, and then you can turn it into a geometric series.
Okay, so this is 1 plus d squared plus dot 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 dot, right?
Mm-hmm.
And then you want me to call this y equals 0, I guess. Yeah, I mean that does work actually. Yeah, 0 is equal to 0 prime plus 0 double prime. Okay. So yeah, this is a geometric series,
Mm-hmm.
which I don't know. We can usually write that as like the summation from n equals 1 to infinity, and then that's just going to be d to the n, right? Or it's as I think it's d to the n minus 1. I think technically, because I think it starts at 0.
Yeah, it's something like that.
It's something like that.
I forgot. I just went straight to the
But then I
series
know.
solution.
Yeah, I know what the solution for that is, right? The solution for that, so Sn is equal to, I think it's like a naught over 1 minus r. Where this is like r. So, what? That gets you y is equal to d, and then this is going to be 1 over 1 minus d.
Yep.
Okay. Okay, cool. I'm cool with this so far.
Alright. And then from there, you can move your 1 minus d over to the other side.
Okay, so let's move this over here. So, am I going to factor out the y?
I believe from there, you could, once you move the
Oh,
1
actually,
minus
sorry.
d over, you can just...
So you want me to multiply on both sides by 1 minus d, right?
Yeah.
Okay,
Yeah.
so 1 minus d times y is equal to dy, right?
Yep.
Okay.
And then from there, you can just do your derivative operators again, right? So
Mm-hmm.
you'd get y minus y prime is equal to y prime.
Okay, so if we put that in, yeah, so y minus dy is equal to dy. Oh, so y is equal to 2 dy?
Yeah.
Fascinating. Okay.
Which from there is just a separable differential equation that you could solve.
All right, let's see. Okay. So, let me like write this. So y is equal to like 2, and then we would say like dy dx.
dy
basically.
dx.
Yep.
Yeah.
Okay. So then I would move this, and I move this. So I get dx is equal to 2 dy over y, and then this is ln, right? Okay. So you get that x is equal to 2 ln of y, but then technically plus c, right?
Yep. Mm-hmm.
Okay.
And then you can just exponentiate, get to your exponential like you normally would.
Okay, so divide by 2, and what I get that y is equal to c e to the x over 2?
Yep.
I think so.
Mm-hmm.
And then what is I guess it's a family of solutions, right? C can be whatever. We weren't given any
it's a
boundary
family of
conditions.
solutions, and let's see, here's where I found it from. I'm gonna just
because this is what like I
screenshot
kind of predicted, right? I was like, oh, it'll probably be like e to the ax or something. But
yeah, and then let's see, where is it? Somewhere over here I have they when they posed a problem with the solution, there's like a paragraph they put, because there's some specific conditions for how the y of x needs to be. I just forgot where I put the screenshot.
all right, go find it. You're good. What's up, Green?
Oh, I see it.
Thanks for the follow, Connor.
It named the GP because they put it all in like latex form. I'm not a computer, so I can't really read latex form like that.
You're good.
And then so I was plugged into ChatGPT and I was like, hey, write this in something more easily legible. And
Okay, let's see.
instead of putting it as like latex conversion, it made
Here's some more readable
random shit.
prose. Okay. For this solution to actually belong to the same weighted space, x of p, Taylor series must also satisfy the normal. Oh, okay. Is this like where?
Yeah, so they go into it needs to work in like a specific Banach space, and the
I've never heard of
derivative
this.
operator has to have a norm such that that geometric series converges.
Right. Okay. Yeah, and yeah, that only works when I guess it's less when the whole thing's less than 1. So then you need p to be less than 2. Oh, okay.
Yeah, because if your d is greater than 1, it won't converge.
Right. I feel. Okay, cool. That was a fun question. Yeah, I think we did it. Yeah.
It was. Yeah.
Nice.
Yeah.
Thank you,
I was
Breasticles.
looking for some PDE to submit, but
You're like it's my birthday. Don't be too mean to me. You know.
it was more the fact that Amazon saved you because it was
Amazon
supposed
saved
to
me?
arrive today. Yeah, it was supposed to arrive today.
Do you have a
like
book coming in?
4.5 hours ago.
Uh-oh.
Yeah, and it still hasn't arrived. So
Dude, that's the worst. I have been, dude. I ordered tires like for one of my cars like a week and a half ago, and they still haven't arrived. I'm confused. Like, where's my stuff?
yeah, people are getting like complacent with the shipping. I
Yeah.
ordered another book and it's been like a week, and it's not supposed to get here until the 13th to the 15th.
Ew.
They haven't
What?
even shipped it.
Surprise, motherfucker.
Damn. Infinite derivatives, Raven. Yes, they were some infinite derivatives we did. Cool question though. Okay, but when you get your book of pain, I guess so tomorrow you'll have some fun ones. for us.
Probably, yeah. Yeah,
Okay,
it's a book on like applied PDEs.
Yeah.
And then I got another one that is, and I quote, the name of the book is 500 Examples and Problems of Applied Differential Equations.
Oh no.
So I'll have plenty in the future.
That was fun. Shush says it's not letting me submit my question. Well, try doing it again. I have seen this before, Shush, where like it says something like token doesn't work or whatever. If you just do it again, like go to the website again and try to upload it again, it should work. I thought I fixed that, but some people are able to submit. Like Connor, thanks for the follow, by the way, Connor. Random dude gladiator. Okay, cool. Let's spin. Let's see who we're gonna get for our next question.
Let's go gambling.
Random dude. I remember random dude gives me like kind of tough questions. This is the dirt question. Your dirt got picked at least. Oh man. Dirt. Fucking dirt. Yeah, I have no clue how to do this. Okay.
I don't know how to work with dirt. Oh, thanks for baby voice. Yeah. You got the Bruscles luck today? Uh-oh. That's too funny.
He's just moving around the shadow band. I think that's what you should vibe code next time, is like, at some point in the stream, one person's gonna get a random shadow ban and just never get picked.
Oh wow! Like, yeah, just randomly, just like have the worst luck.
Pick one.
Yeah,
but make sure to vibe code in there an exception for me.
Yeah. Shush, what is it saying? What's it? It says it's saying the same thing. What is it saying? I'm curious. Let me know why it's not working. It should be working. What's up, Poison? Good to see you.
But it's never the bad people that get shadow banned.
I know. It's only the best people get shadow banned.
It's always the normal people, never the trannies.
Oh no.
Are we allowed to say that word? I forget.
You can say anything you like. Nobody cares anymore.
Well, TikTok does at some point. They give me like the notice of like you're promoting self-harm or something.
Oh shit,
no.
Self-harm? Well, no, because they're harming themselves, so then it's not up to me.
There you go. There you go.
And if Chink Chok wants to have a go at me, then we'll have a conversation in person. Know what I mean? I don't hide behind a keyboard.
Yes. I know all the people in my town. Oh yeah, see, look, dude, I got the violation warning. My live is flagged for hate speech and hateful behavior. Okay, so yeah, don't say that too much, Sensation. They get upset at me. It says hate speech.
I'm genuinely going to go have a word with these people, methinks.
Yeah, go have a word with them. Dirt, I don't know how to do this question, but this is fun at least. Let's see. Yeah, like horizontal normal stress, vertical normal stress. Oh, it says token blah blah blah. All right, shush. Let me see one sec. Let me make sure this works. All right, if I go to actualofficehours.com and I drag in a screenshot, I'm gonna like say test, and I hit upload. Yeah, mine works. Try it in a different browser. I think there's something with the cookies and stuff that like makes it.
Yeah, with the security token, it sometimes gives me issues, so I gotta just change browsers. It hasn't.
Yeah. Maybe. So that was put in place because we wanted to make sure like someone found a way to just bot submitting thousands of Shrek photos to my thing.
Oh no.
It was kind of annoying, so I had to vibe code some sort of security thing to check the browser. They flagged it for hating on mice. Yeah. Anyways, okay. Well, at least that shows to me that it works. So try a different browser, shush. It should work. Okay. This question about dirt. You can just forget about my handwriting in this photo. You have decent handwriting. I see this. You're right. This is like 250. This is like, I think this is 39. This is a 39. It looks like 3G to me. Or 30. Crazy. Let me see. Let's just throw this one at AI, honestly, because I don't know much about dirt, you know. But I'm gonna learn about dirt with you. Solve this one. What's up, Abdul? Even chat is like taking a while to think about the dirt. Oh man, I have so many text messages because it's my birthday. Everyone's just like, oh, I love it, but then also like, it's also a lot.
Better than none.
Yeah, it is better than like no one hitting me up on my birthday, but then also I have to like respond to like all these people. I'm just like, I love you guys, but it's kind of stressful.
Oh no.
Dude, all right.
It's kind of like that when I got in my my car crash. I posted on Instagram like,
yeah,
yo, for everyone asking, I'm good.
Yeah,
I'm fine. I'm alive. And then everyone who saw my Instagram post proceeded to message me and say, "Oh, are you okay?
Yeah, are you okay?
Like, why do you think I?"
Yeah, like, yeah, I made the post and I'm okay.
Yeah, I like went to bed then I guess the next morning and then fucking I opened up my phone to literally like 150 messages, and I was just
Wow.
like, for the love of God, stop! Like,
Stop. I'm
I mean,
okay.
I was like, and half of them I was like, dude, I met you like one time at a party, like 2 months
Yeah.
ago. Like, I know who you are, but
Thanks, Bob. I get it. Yeah, no, it's one of these things where what's it called? Not like humble bragging, where it's like I want to say also like white people problems, but like it's where like something is great, but like it's kind of an annoyance, and you shouldn't be like annoyed at it. Yeah, exactly. Yeah, like it's nice that a lot of people cared about, you know, if you got in a car accident, like, are you okay? I think maybe they're more of doing it for themselves to like show that they care. Maybe is that works.
something
like that. Okay, let's learn about dirt. Okay, engineering is very interesting because engineering has a bunch of just random equations. You come up with stuff. So, Gemini seemed to like come up with some decent answers. So let's try to like see what it says. Because you asked for the normal stress. Okay, so it says across a vertical discontinuity, the normal stress and shear stress must be equal for both sides to maintain an equilibrium. Did they say this was at equilibrium? I guess so. I mean, it's kind of, they don't really say it, but yes. I love it. They call it like a frictionless wound. Like what? Anyways. So yeah. Stress on A has to equal stress on B, I guess. Oh, these are two different like layers, I think, of dirt. It is kind of similar to buoyancy, I guess. To find the and then what was it? The vertical normal stress, the magnitude of the shear stress. I guess this is like an equation you use. Where this looks like you're subtracting and then dividing by 2. Like why? Okay.
It's usually a sum total.
Yeah, I don't know. Oh, okay.
N times n plus 1 over 2, right?
Yeah, I mean, if we were averaging, I guess it's just interesting when we subtract them. But okay,
No, the sum between 1 and 100.
The sum between 1 and 100.
Is that n times n plus 1 over 2?
It is. Yes. It's yeah. You're right. Yeah.
I think it's because they're trying to find equilibrium.
Yeah. Okay.
It looks like something about equilibrium, so they're taking 1 point, another point, subtracting, dividing by 2, I believe.
Oh, it's like the midpoint. This is kind of like the midpoint, I guess.
Yeah.
Yeah. Okay. Cool. All right. Cool. Good question about dirt. Thank you. You didn't get shadow banned this time, but we'll put the solution for this here in the server for you. I'm just gonna call it dirt. A dirt question. All right. Let's see. Let's see if Gladiator is still shadow banned from getting his question answered. And then Connor has one as well. Cool. All right. Let's spin. Choose a winner. See what we get.
Let's go gambling!
You're not shadow banned, Gladiator. Someone said I have 1 testicle. Wow. It's a great username there.
Whenever someone says that, it just reminds me of Hitler every single time.
Oh yes, yeah. He apparently had 1, right? That was maybe a cause of his manicness or something.
Because it was a song throughout the entire Second World War.
Oh, was
I can't remember to what
like
what
the
tune, but it's like
the Allies would like just sing it.
He only has 1 ball. He left the other in the Albert Hall.
In the Albert Hall?
His mother, the dirty bugger, something, I can't remember how it goes now, but yeah, we were taught this in my primary school.
No way. I was taught like you know, Pop Goes the Weasel, not like Hitler has 1 testicle.
Oh shit, not good.
So basically, this is Yorkshire we're talking about, and there's an old army camp that was turned into a museum.
Mm-hmm.
And every primary school child gets taken to this place called Eden Camp to learn about the Second World War in its entirety.
Oh, wow.
Smells and everything. It's fucking horrible.
Yeah, that'd be awful.
Oh, no.
It's basically an entire museum that smells like rotting meat.
Yeah, it's like durian. Okay, let's see. Bromine melts at minus 7.25. It boils at that. The enthalpy of fusion is that. The enthalpy of vaporization is that. The specific heat... Oh, wow, there's a lot of stuff here. Okay, what is required to convert solid bromine to the gas phase? Oh, wow, we have to go through a lot of phases here. I could probably find a graph for that. I don't know if I want to draw this whole thing myself. What's the name for this? It's like heat diagram... states. Yeah, okay, I want this. Yeah, I want this graph. There we go. This is what I want. I want this. How do you all know this? I don't know. You pick up some random knowledge over the years, I guess.
It's called osmosis.
Yeah, we just absorb it. Okay, so you have... And I wouldn't put this as time, right? We're gonna have this be like heat added. Yeah. Okay. This is what I want to say. Okay. And then this is like temperature. So when you have stuff that's like a solid, as you add heat to it, the temperature will like increase until you get to this this like flat part, and this is where melting happens. And so now the additional heat you add does not raise the temperature of your material. It actually gets put into breaking the bonds that are holding it together as a solid, and then that's why it starts melting. And then once it's melted, now every additional piece of heat you add starts to raise the temperature of the liquid you have, until again you get to the boiling point. And at this stage, any additional heat you add does not raise the temperature. It works towards, again, breaking whatever intermolecular forces there are that are keeping it together as a liquid, for it to now be free as a gas. And then once it's a gas, you start adding more temperature, and it starts getting hotter and hotter. So, we have stuff that is starting as a solid. So we can say like this is where we're starting. Gladiator, like we're starting down here, and then we want to know the amount of heat required to convert it from solid to something up at the gas phase up here. Wow. Okay. Cool. So we have to go through all the different like the different processes. So the first thing you're going to have is this, which is raising the solid up to the temperature at which it starts to melt. So we can come up with that. So this it's the same MCAT, Q equals MCAT, right? MC delta T. But we need some stuff. Okay. So I need this. That's the specific heat of liquid. What's the specific heat as a solid? Wait, the enthalpy of vaporization. Yeah. So this is going to be this thing. That's the vaporization. The specific heat of the liquid is this. Thanks, Pineapple. Appreciate it. But where is it as a solid? Oh, and then this is the specific heat of it as a liquid. Interesting. I think there's missing information here. Enthalpy of fusion, because that's going to be this. Oh, interesting. Oh, I see. They tell us that it's already in the melting phase. Okay, so actually we're not starting as a solid and heating up. We're already at the temperature at which it melts. Aha. Okay, cool. Got you. So, okay, because I was looking at that, I'm like, I don't have the specific heat of it as a solid. Okay. So we're going to do this part. And this is always just equal to, so that like energy is going to be equal to, I want to say it's like delta H of fusion. And then times the mass, basically. And so let's see what we got. So, enthalpy of fusion. Fusion is like going from liquid to solid, or solid to liquid. And so that's 10.57 kilojoules per mole. So here we say 10.57 times 10 to the 3 joules. It could be mass or it could be moles. It depends. They give it to us in moles. So you're right, Gladiator. This is going to be in moles. Yeah. Sometimes it's given to you in grams. But they say per moles. Okay. So then we need to know how many moles is 25 grams of bromine. So that's the first thing we gotta go figure out. We gotta go figure out this. So we're gonna say like how many moles is equal to 25 grams of bromine. Okay. So then we gotta go look on our thing here. So periodic table. Bromine. And bromine is so 79.9 grams per mole. So we're gonna say 79.9 grams of bromine is 1 mole of bromine. So then divide that out, right? Let's see what we get. .25 divided by 79.9, and that's 0.313 moles. Okay, cool. Okay, so then this is this times 0.313, and then that's the energy required to melt the bromine. So to get it from its like hybrid of solid and liquid state to like purely liquid. Okay, so that's one component we got to do. So let me just do that times 10.57 e to the 3, and that's 3307.26 joules. Okay, cool. That's for it to melt. Now we got to get it from melting to boiling for it to get into the gas phase. And so that phase right here, we'll use a different color for that one, Gladiator. Let's do this. This is going to be Q is equal to MC delta T. This is where mass comes in handy, because that's going to be 25 grams. And then the specific heat as a liquid is 0.474. And then delta T is like how much temperature do we need to go to get it from a liquid up to a gas. And that we have to look at what its melting temperature is and what its boiling temperature is. So it melts at negative 7.25, and then it boils at 58.8. So that change in temperature is going to be your final temperature, which is 58.8, minus your starting temperature, which was minus negative 7.25. There we go. And that's all in like, yeah, joules and grams and stuff. So cool. Let's do some math. 25.474 times 58.8 plus 7.25. And what do we get for that? Yeah, okay, so that's 782.7 joules. Okay, cool. Great. And then what else do we need to do? Oh, they want it to be like, I think fully in the gas phase. So then we need the enthalpy of vaporization. So then we need this. And then that component is the same thing as we did for the melting. So I'm going to say delta H vap times moles. Which in that case, delta H vap was what? 29.96 times 10 to the 3, and times 0.313. Alright, so let's do it up. So 29.96 e to the 3 times 0.313. Or we can just say like times this number. And that gets me 9,374. Nice. Joules. Okay. So then now we're done, right? Because we got it up to the gas phase. And they don't need it to be any higher temperature. They just want it to actually just be boiling completely. Yeah, this is kind of a fun problem, right, Flask? Yeah. So now you just add it all up, right? So this was the energy required to melt it. This was the energy required to bring the liquid up to boiling. And then this is the temperature required to fully boil it or to like vaporize it. So we're going to do that. Plus. And then the key thing here that students always mess up is you got to remember a lot of these delta H vap, delta H fusions are in kilojoules. So you got to multiply that all by 1,000. So there you go. So then total, once we, put all the numbers together, that's going to be 13,464. Or you could say like 13.46 kilojoules. Why do we multiply by 0.313? Right, good. Okay, so that's the number of moles of bromine that we have, right? And the moles of bromine we got from knowing that we had 25 grams of bromine and using the periodic table, I guess. Does that make sense, Gladiator? I think that's it.
Remember, you have to say exactly as it's written.
The answer shows 7.12. Uh-oh. Did we screw up somewhere? 7. Where would they get 7.12 from? Sorry, what? Like the full answer, the total answer is 7.12? Oh, wait a minute. I think I might know, actually. Uh-huh. Okay, bromine is Brinkelhoff. Sorry, so bromine is actually BR2. Yeah, okay. So, how many moles are in 25 grams of BR2? That's the key thing here. So you gotta multiply this by 2. Yeah, okay. Well, you have to divide it by 2. Okay. So this is actually 0.313 and then what like divided by 2. Yeah, because then you would do this. You would say, what is it? 1 mole of BR2 is equal to like 2 moles of BR. That's technically the part. All right, let's see. 0.313 divided by 2. Or I can get the full number. Thank you, Endeavor. Appreciate it, dude. Yeah, I'm here on my birthday doing chemistry. I couldn't be spending it any better, honestly. Okay, I see. So let's make this 0.156. Here, let's like divide by 2. So that one's gonna get divided by 2, and then I think this one's gonna get divided by 2. But there was no moles here. Thanks, Connor. All right, so let's see. So let's do our original answer. The cursed Brinkelhoff, dude. There's always like exceptions in chemistry. Okay. So divide by 2. Okay, that plus. I think we can still do plus the 782 because that one's not divided by 2. And then now we're gonna do plus the 9374 divided by 2 though. I'm still getting a high number though. I'm still getting 10.15. 10.15 kilojoules. Let's see if that makes sense. Wait, no, that doesn't make sense. Sorry. This should be 1,500 plus like 4,500. Yeah, no. What went wrong here? Excuse me. One sec. I see. I added the wrong one twice. I see. Calculator error. Oh, sorry. My bad. All this will be replaced by AI at some point, just like input errors. Okay, here we go. That divided by 2. Plus the 782. One sec. I gotta go find it. Go find it. Okay, plus that. Plus this divided by 2. There you go. 7.12. Yeah.
That's dope.
All right, we did it. Okay, cool. So yeah, now you get 7.12 kilojoules. Yeah. Okay. Just divide by 2. But nice. Yeah, you gotta remember, Brinkelhoff is, they call it like a diatomic? I think they're called diatomic elements. You're welcome, dude. Yeah, that was fun. Gladiator. Cool question. Oh, man. Okay. Let's go see who's the next question we're gonna go through. Let's go pick a winner.
Let's go gambling!
Is it gonna be Connor? Or is Lucky Cat gonna hold up to their name? It is gonna be Lucky. It is Connor. It's Connor. Okay, Connor, what do you got for me? Ooh, oh, this is cool. Index of refraction. I like this. Yeah, that's a physics question. This is actually very related to what I will teach over the summer at UCLA, because this is optics. All right, green laser light travels from air into an unknown material. Okay. So here, let's come with like the 2 different scenarios, right?
Before you begin, do you want to say it
up?
or should I?
You can say it. Is laser spelled wrong?
Learn to take screenshots. You didn't notice, did you? Someone's taken a photograph of a screen. It's
They have taken.
really
Yeah,
fucking obvious.
I see. That's why there's this cute like glow to it. I like the glow.
You are literally using a computer. Literally.
But maybe they're like on their phone, like on the street.
No, but the thing that they're reading it from, it still has the capability of taking screenshots.
I know. On Windows, honestly, it's not super intuitive how to take screenshots.
That looks like an iPad, I think.
Oh yeah, maybe it's an iPad. Yeah.
Because if you look down at the bottom of it, there's like click button for the keyboard, and then
Connor says I don't have TikTok on my iPad, so it doesn't distract me. Okay, so I can approve of this.
Yeah.
Connor does not have TikTok on their iPad.
But I can never approve of gay pads, so.
Yeah. Connor, you're totally okay. Good on you for identifying that you would have something distracting and you need to like not have it there. It is a literal screenshot. Yeah, it is a shot of a screen. Anyways, okay. Green laser light's coming in. Cool. And the angle between the beam and the normal is 48 degrees in the air. Okay, so that means this is the what's that? Let's come with a different like color. Okay. And then we have the laser coming in here. And this is going to be 48 degrees. And 29 degrees into the unknown material. Cool. So it does this. I think this is just Snell's law. And this is n equals, I don't know. We'll just call it like n2. And we'll call this n1. Right. So by Snell's law, n1 sine theta 1 is equal to n2 sine theta 2. Would you rather watch a tree grow or... God damn it.
Oh, no.
Shush. You almost got me, dude. Don't get me banned on TikTok, please. I have TikTok on my phone and I never use it. Self-control. Wasted storage. They do take a lot of... Yeah. Dr. Gold was born on Easter Sunday. Yeah, Easter moves, though. Blue. So my birthday is always April 5th. But Easter is always, like, whatever Sunday. So sometimes my birthday's on Easter. Sometimes it's not. Anyways. So this is 1 sine of 48 degrees is equal to... We don't know what n2 is, but then that's sine of 29 degrees. So you just move that over. Okay, so n2 is equal to the sine of 48 over the sine of 29. So let's get a number for that. Make sure I'm in degree mode, right? Okay. Sine of 48 divided by sine of 29. 1.53. Cool. Okay. So that's the unknown index of refraction. And then they want to know, what is it? The speed of light in the material. So I think how that works, I think N is equal to C over V, where this is like the speed of light. And then this is the velocity in the material. Right, okay. I think that's how it works. I think N is C over C. N is equal to C over V. Yeah, N is equal to C over V. Okay, cool. So, that tells me that V is equal to C over N. So that's going to be C divided by 1.53. This is my favorite topic. You can link it to power cables, which is to do electricity and data transmission, yeah. Or like fiber stuff, yeah. Okay, cool. So, and then the speed of light is, in vacuum, is 3 times 10 to the 8th. So we say 3 e to the 8 divided by this 1.53 number. And that's going to give us a really, really, really big number. But I think we can say it's equal to 1.96 times 10 to the 8 meters per second. And there you go, Connor. Hopefully that makes sense to you. Great question. Cool physics question, Connor. You make it so easy. Yeah, sure. It doesn't have to be super, like, difficult. So, Connor, I'm going to save this question. And then what we always do, it's kind of a fun part of the stream here. Anytime you submit a question to our website and we go through it, it automatically gets posted into our Discord here. So, so if you click here, it has a link also to the YouTube recording, and then I'm going to post the screenshot in here for you as well. So, and then if you join our Discord and, like, I don't know, just like comment on this or something, or react with an emote, we'll give you credit for asking the question. And, like, every time you ask questions, you earn points, and when you earn points, you get gift cards. So that's how it works. So yeah, go. The same website used to submit your questions, actualofficehours.com. You can also join our Discord there. There's a link for it. Okay, let's see. Dun, dun, dun. We did this question though, right? Testicle person? I'm pretty sure we did this question. Yeah, I'm very sure.
Yeah, we did. I looked at it, and it was Starvin' Marvin's.
Starvin' Marvin. Okay.
Yeah.
Starvin' Marvin.
The screenshot didn't get posted, but we had done it. And
where did we? Here, I have it. I have it somewhere here. I'm very sure. I even, like, I think it was in the last day or so. Was it not? This was fun doing circuits. I appreciate it.
I think it was like right before that. Yeah.
Yeah, it was this one. Yeah. You're awesome, man. Thanks again. You're welcome, dude. Thanks, Connor. But yeah, so there you go. The solution, we did it for this one. It was -4 to -5/3. You've seen me do it? Yeah, I think I did it yesterday. Or not yesterday, sorry. On the last stream, which was on Thursday. But that's also in our Discord. I'll post the link to it as well on the thing. Dun, 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 dun. Yeah. Oh, I didn't actually send the screenshot for this one. Oh, I should have. One sec. Let me help you on that one. Here, Starvin'. There you go. Okay. Sometimes I forget, or I'll post it like the wrong thing. Yeah, the Kirchhoff problem. Yeah, that was fun, wasn't it? Why is Discord loading? Okay, let's see what the next question is coming up. I got 36 minutes. Let's go choose a winner. Who's it gonna be?
Go gambling!
Apply Kirchhoff's law. Yeah, that's a funny one. You go find the loops. Lucky Cat, it's your day. Lucky Cat is lucky today. What's up, Fanatic? Can you help me solve the one from the last stream? Which one was it, Pineapple? Do you remember? Let me go see which one it was. Oh, this one. Yeah, no, I think I got it. Yep. I got it. I got you. Got you. Thanks, Taco Cat. I am Unk status. Yeah, I'm getting up there. Okay, let's see. Given the function, state all intervals of increase and decrease. Cool. As someone who just finished their physics PBA, this gives me a headache. Yeah. Okay, so increasing is where the slope is positive. So slope is negative here. Slope is 0 here. Slope is still negative here. I would say from here on out, it has positive slope. And let's see, where is that point? That's like, is that like, ooh, what is that? Is what, 1, 2, 3, 4. Oh, so these are by 0.2. This is like 1.2. Okay. So I would say 1.5, but it doesn't include 1.5. Right, 1.5 is where the slope is actually 0. So I would say 1.5, comma, infinity is increasing. And then everywhere else is decreasing. So the way to, well, actually, no, not everywhere else. You just gotta be careful about that. So from negative infinity to wherever this inflection point is. So I would say negative infinity, comma, 0. And then you have to say like union, because it doesn't include 0. You gotta be careful about that.
Oh no.
And then it's from that up to this vertex. So I'd say 1.5, decreasing. State all local max and min values. Well, there's no local max, right? Local max means, first of all, first derivative has to be 0, but also the derivative has to go from increasing to decreasing. Here it goes from decreasing to flat to decreasing. So that's not a max or a min. Here, this is a local min, though, because here the first derivative is 0, and you're going from negative slope to positive slope. So I would say there's a local min at x equals 1.5. State all intervals of concavity. Wow, that's kind of fun. Okay. All right, so concavity has to kind of do with like curvature. So I like to always kind of like see like, oh, okay, is this like a happy face, right? Or is it a sad face? So this to me looks like concave up from here to here, right? This is kind of the happy side part. And then this is concave down. And then I think it must switch here because then it becomes concave up again. So I would say concave up from negative infinity to this inflection point. So I would say concave up. Concave. From negative infinity to 0. And then also concave up from, I don't know, that looks like 0.8 to infinity. So union 0.8 to infinity. Okay. Then concave down. I would say, again, from 0 to wherever that other point is. So it's like from 0 to like 0.8. Yeah. Okay, state all the points of inflection. Does concavity have to change at an inflection point? Because if it does, then I would say at 0, let's say like at also when we state the local min, we should also put the y value. So that's 1.5, and then I don't know, it's like y is equal to, what is that? like 3.8 maybe. Inflection point, I think, is going to be at 0.7, because that's where the second derivative is 0, and it's also switching. Yeah, inflection points are where f double prime switches signs, not just when f double prime is 0. Yeah, I always get messed up by that. Yeah. So here, you're also switching, right? You're switching from concave down to concave up. So I would say also at, what's that, like 0.9, 5.5? Say like 0.9 comma 5.5. Nice. Okay. So I think that's, yeah, because I think you're just looking for when the second derivative is switching. It's not, yeah, it's not perfectly analogous to critical points, which is just when it's, yeah, exactly. It's just when f prime equals 0. But also, okay, so I think when, and this is what I was doing earlier, right? When you define like mins and maxes, you have to talk about whether the slope is changing sign. Does that make sense, Pineapple? Blue's got some comments too, apparently. The 0.9, 5.5. I think that's from here, Pineapple. So I think this is like 0.9-ish. And then the Y value is like, I don't know, 1, 2, 3. I mean, wait, 1, 2, 3, 4. So this is definitely 5. Okay, so maybe it's like 5.4. Yeah, I think it's like 5.4. That's just another place where, again, this part, right, has to be concave down in terms of curvature. And this is concave up. So there must have been some point in between where the concavity switched. Yeah. Inflection points are more analogous to local extrema. Yeah, I agree. You learn about this also when you do like titrations and stuff, right? Titrations have like this like behavior, and then you're always like kind of looking for the inflection point. And 0.7, how do you know it's inflection? Okay, so 0.7 is also an inflection point, because again, this is concave up, like this is the left half of concave up, and then this is the right half of concave down, and so the switching happens at 0.7. What is titration? You know what titration is. That's a chemistry thing. Yeah, just whenever the concavity is switching. You got it? Cool. Nice. You're very welcome, Pineapple. Glad it makes sense.
Well done! Well done!
Alright, let's mark that one as done. We'll put it in the Discord. I remember doing titrations last year. There's a way you can cheat on titrations, because right, you have to like slowly add either acid or base until the color just barely changes, and that's called an indicator, which I think a lot of times it's a pink thing. Is it phenolphthalein? Is what it is? Yeah, you try to get the lightest pink. So if you go too much and it becomes too dark, you can always cough on the, this is like a cheating thing. Yeah, you can cough on the liquid, because what happens is the CO2 released from your breath, right? So we inhale oxygen, we exhale carbon dioxide. That forms carbonic acid with the water, and it'll actually like kind of reverse the titration. I'm working on figuring out a beefcake of a Kirchhoff problem if this PD doesn't come in tonight. He's like, come on, dog. Yeah. No, it's a common thing. Because I think you're titrating a base usually, right? Isn't it usually a base into an acid? And so if you put too much base, the way to like neutralize it is for your breath to form acid, and then it'll neutralize like the too much titrant. Yeah. I think coughing not during pregnancy, during titration. Wait, titration, carbonic acid. Ugh. Well, okay. Anyways, it works. I can't find it on Google, so maybe it's actually a really well-known secret. Yeah, titration is when you slowly mix something into another thing until it just barely happens. Yeah, so in a titration, usually what's happening is you have an unknown constant. Titrations are how you can determine what the pH of something is, or like not what the pH of something is. The indicator tells you what the pH is, but titrations are how you can determine the concentration of an acid or base you have that's unknown. So, yeah. Titration determines the unknown concentration of, they call it an analyte, by adding a reagent of a known concentration until it reaches completion, yeah. So, what happens, is you have some unknown amount of, I guess in this case, you have some unknown amount of acid, and unknown concentration. Like, you don't know how acidic or how, like, concentrated this thing is. And you will start putting in a known concentration of base really, really slowly. And what you end up having is called an indicator here. And the indicator changes color once, in this case, I think, once the pH is neutral. And when the pH is neutral, that means you've added enough base to cancel out the amount of acid in the liquid. And because you can then calculate, oh, I know how much base I added, that can tell you how much acid was in your unknown solution, and you can figure out the concentration of it by doing that. Right. And yeah, it'll barely change colors right as it crosses that neutralization pH. One group forgot their indicator, just kept adding base. Yeah, if you don't have the indicator, you're gonna like keep adding base and it'll never change color, and then you've ruined your sample. Yeah. Anyways.
Why do you keep calling alkali base?
Alkaline is basic, right? Yeah. You guys just call alkaline. You don't say base.
Alkali, plural.
Alkali. I guess those are another thing. Yeah. This is the color you're always like shooting for. You're trying to get like this like barely pink. Yeah. If it's too pink, then like if it's this pink, then you messed up. But also, yeah, what I was getting at in terms of inflection points, it's the same type of curve. You see how this is like concave up, and then it goes to concave down, and then the point at which it switches is technically also an inflection point. Yeah, you done messed up. Hey, Ron. Do you have to know what type of acid you neutralize with that? Well, okay, so it does help to know if it's a polyprotic acid, for instance. So, and what I mean by, sorry, I'm going on a little bit of a tangent, but I mean, this is fun. Titrations are fun. So for instance, HCl, hydrochloric acid, is a monoprotic acid. So it'll break up into single H plus Cl minus. If you have something such as sulfuric acid, which is H2SO4, technically this will break up into two H pluses and an SO4 2 minus. And so when you're finding, and when you're neutralizing, usually you use a strong base such as like NaOH, which will dissociate completely into like Na plus OH minus. And so what you're doing is, you know how much of this that you're pouring into your analyte, and you can be like, okay, well, the amount of this I poured in has to equal the amount of this that it neutralized. And then from that, you can then figure out, oh, well, what's the concentration of the original acid? So, but yeah, you do need to know whether it's monoprotic or diprotic, because you want to know whether the acid is contributing a single hydrogen ion, or it's contributing two when it dissociates. Or if you don't follow procedures like licking it. You only mess up in chem when something blows up, or you wake up a day later without any memory of it. Yeah, right.
Surprise, motherfucker.
Yeah, very interesting. Yeah, no. Chemistry's cool, man. If I hadn't gone into physics, I think I probably would have done chem. It's a decent amount of math still, but also I like the kind of the experimenting side of things. The only thing I don't like about chem are all the exceptions. There's like infinite number of exceptions in chemistry, and those can get annoying. Yeah, and you can, yeah, it's cool. We gotta cook, Jesse. All right, let's see. Next question, probably last one, I guess, unless someone else submits one, is from Webster. We're still gonna spin the wheel because there is, I guess, a non-zero chance that he would get selected. Nice, Webster. Thank you, Ashley. Appreciate it. Thank you, Ash. Yeah. Wow, $2. Thanks for the donation, Rex. Lucky cat. Appreciate that. Thank you. Ooh, okay. We are gonna do some physics here. This is physics. Appreciate it. I can't join VC, but I want to say happy birthday. Thank you, Ashley. Appreciate it. Ashley's been in our server since forever. Like when did you first join? Let's see, ModView. You joined, yeah, April of 2022. Wow, 4 years ago. Isn't that crazy? Thank you, Alistair. Appreciate it. Taking my bird on a walk. That's cool. Wait, like you have to, I know, like you have to like walk a dog. You also have to like walk a bird. Okay. Let's see. A railway carriage, when occupied, has a mass of 700 kilograms. On a journey, the railway carriage ascends a smooth plane, which is inclined 18 degrees to the horizontal for 30 meters. The speed of the railway carriage at the start of the incline is that, and at the finish of that is 10. Calculate the deceleration. Okay, cool. How do you genuinely take your bird on a walk? Like, shouldn't you take your bird on a fly? I think maybe Ash is just going for a walk and the bird is chilling on Ash's shoulder or something. Okay, so deceleration. That's going to be equal to the change in velocity over the change in time, which is always like v final minus v initial over time. So the final velocity is 10. The initial velocity was 18. And then it happened... well, they didn't tell us, actually, the amount of time. Fascinating. Okay. They did tell us the distance, though. Okay. This is actually kind of fun. This would require the time, but we don't have the time.
You done messed up, Aaron!
So we can use another equation. So this actually doesn't work. Yeah, don't use this equation. This is the cool thing about physics. You can like try one way and be like, this isn't working. We gotta do something else. The other one is this. So VF squared is equal to VI squared plus 2A delta X. This is another key equation that you'll use. So final velocity squared, so in that case that is 10 squared, is equal to initial velocity squared, that's 18 squared, plus 2 times acceleration, and then the change in distance is 30 meters. Okay. So now we just move some stuff over. So 100 is equal to, I don't know what 18 squared is. It's a big number. 324. Plus 2a times 30 plus 60a. Okay. So we move that over. So I get negative 224 is equal to 60a. Divide by 60. So 224 divided by 60. And you're going to get a is equal to negative 3.73. Which I guess is deceleration because it's negative. Meters per second squared. Cool. So there you go. That's the first part. Let's see. Oh, Presticles, you submitted one as well? Okay. Is it the Nightmare Kirchhoff question?
No, I'm still working on that, figuring out the, like, setting it up. We wouldn't have time. Probably wouldn't have time anyway, but
yeah,
I realized I submitted the wrong one, but I'll send the correct one. We already solved the one I submitted.
Okay. Calculate the tractive force? What is the tractive force? I've never seen this word before. What is tractive force? tangential force generated by a vehicle to move over a surface. Yeah, wait, what? I've never heard attractive force before. The force used to generate motion between a body and a tangential surface. Okay. Maybe it's the mass times the acceleration.
I think the tractive force would just be another way to say your friction.
Yeah, just friction, right?
Because if the wheels are spinning, there's just static friction.
Well, I think we can use like conservation of energy to figure out like what the speed should have been, right? If it went up 18 degrees for 30 meters, and then yeah, wait, attractive force. Okay, I think I see how this is gonna work. Okay, let's do conservation of energy. Okay, first we're gonna do this is a super funny question. Okay, conservation of energy. Free the bird. Okay. So let's assume potential energy is 0 at the bottom, and then kinetic energy is gonna be 1/2 times 700 times 18. 18 squared, right? So this is at the bottom. And then at the top, potential energy is now going to equal 700. So M times G times the height that it ascended. And you have to kind of like draw a triangle. So in this case, this is 30 meters from here to here. And then this is 18 degrees. So this amount here is 30 sine of 18 degrees. That's the amount of like height that you increased as you went up the incline. So we're going to say 30 sine of 18 degrees. And now the kinetic energy is equal to 1/2 times 700 times 10 squared. Okay. And let's calculate what the total energies are. My guess is this total energy is going to be less than this, which means that we had to have lost some energy due to friction. So let's see. So 0.5 times. She can't fly, so we have a carrier that she loves to go and walks in. Oh, that's cute. Second one. Oh, that's such a cute bird. Ash, oh, that's so fun. Ash has it's like a cute little red bird. What type of bird is that? Is it like a cardinal? She knows when it's time to go on a walk. That's so fun. Alright, times 18 squared. Alright, so that's going to be 113400. Good. So this is the total energy at the bottom. And then let's calculate the top. So that's going to be the same thing, but now this is 10 meters per second squared. And then we're going to add that to 700 times 9.8 times 30 times the sine of 18. Ah, and lo and behold, that is less, right? So that's 98595. Okay, so then let's see what the difference. So energy lost. So we're going to do this minus this. And that's a lot of energy, actually. So 14,804 joules was lost. Okay. Now, friction energy, which I guess is the tractive force, that's going to be equal to force times distance. Okay. Which, this is what we're solving for. And then we know the distance. The distance is 30 meters. That's the amount that it went up the track. Okay. So then, so 14,804 is equal to F times 30. You can move that over. And I'm going to call this the tractive force. So let's divide that by 30. So 493 point, I'm going to say 5 newtons. I think that's how it works. Can't you just do the deceleration plus the gravitational acceleration along the plane to find out how much the wheels push uphill? Oh, okay. And then divide by 700. That you know, that might work as well. I see what you're saying. So you're saying that, like, gravity should be pulling down. Let me think what this is going to be. Pulls down the ramp at 9.8 times the sine of 18 degrees, right? So sine of 18. But my actual acceleration is downwards is negative 3.73. So if I subtract those two, right? Let's see if we get the same thing, right? Yeah, that's another good way to do it, actually, Jorgen. I like that. Right, I get. Okay. So this is 3.02 meters per second squared down, right? So then, so like the net acceleration, well, not net, net acceleration. Well, okay. So, acceleration due to friction. Is equal to 0.704. And then you just do like F equals ma, right? And then, yeah, okay. So we're gonna say 700 times 0.704. Yeah, I think you're right, Jorgen. Yeah, I get the same thing. Wow, look, 493, right? Yeah, very cool, actually. This is a much cooler way to do it, Jorgen. I like that. Yeah, you know, this is the cool thing about physics is there's multiple ways to solve things because it's kind of, you know, all together. All the equations are like self-consistent. Like they don't contradict each other, which is nice. So this is another way to do it. Yeah, and it's the same. Yeah, so you can do it both ways. That's kind of cool. Let's see. Okay, and then there was this question, part D. This is a different thing. This is an elevator. What's going on with the elevator here? Okay. An elevator starts from rest with a constant acceleration of 2 until it attains a speed of 4. Thereafter, it immediately begins to slow down with a constant retardation of 3 until it's brought to rest. Calculate the total time for the distance traveled. Okay, that's cool. Okay, so from rest, so we know that V is equal to V naught plus AT for the first part. So that's going to be 4 is equal to 0 plus 2 times T. So T equals 2 seconds for the accelerating part. And then it begins to slow down until it's brought to rest. So that 0 is equal to its initial velocity, in this case is now 4, plus 3t. So then that tells me that t is equal to negative 1 point, or this is negative 3, sorry. So it's negative 3, so then t is equal to 1.33 seconds. Okay, so then the total time is just going to equal to 3.33 repeating. Or 3.3 repeating seconds. Pretty sure. Okay. Distance traveled. Okay, that's where we have to use this. So v squared equals v naught squared plus 2a. You could also use the time, I guess, but I don't like the quadratics. Okay, so we're going to say 4 squared is equal to 0 plus 2 times the acceleration, which is 2. And then we're going to say, like, times x. So this is 16 is equal to 4x. So x equals 4 meters for the first part. And now the deceleration. So then that 0 is equal to 4 squared plus 2 times negative 3 times x. And so that's negative 16 divided by negative 6 equal to x. What's 16 over 6? $2.666667. Okay. 2.6 repeating meters. The second part. So total is equal to 6.6 repeating meters. Oh, it's a government conspiracy. All the 6s. And that's the total distance traveled. Okay, cool. Great question, Webster. I hope that made sense to you.
That's dope.
Riper says, my AP Calculus AB class next year will have over 40 people in it. Whoa, that's a lot of people. But my only other option is to swap with AP Language first period. That period would have less people, but then I wouldn't have either class with the friends, and I'll be like asleep. Yeah, I mean, I would... I would, if you know, like, I'm not a morning person. I do not like the mornings. So, is your concern, Raiper, that if you take your calc class in the afternoon, that there's too many people in it? I mean, that's okay. I mean, I don't know. But when I teach classes at UCLA, there's 190 people in it. 40 is not terrible. I guess most elementary schools are like 20 or 30, or high schools, I guess, per class. But I would prioritize when you know you're going to be awake over the amount of people that are going to be in the class. This is Webster. Yeah. AP Calc is a great class, by the way, too. Yeah, you get a lot of college credit out of it. It's very useful. Okay. It's a good question, Webster. I put it in our Discord, so if you want to go check it out, Webster, it'll be there. Would be some Monty Python shit if it wasn't self-consistent. Yeah, wouldn't that? Yeah. If the physics didn't work out, yeah. Okay. We only got 2 minutes left. I'll look at what Bresticle submitted. I'm just curious. Ooh.
That's dope.
No, that's the one we already did. This was what I meant to submit.
Oh, let me see. Okay. ln of 1 plus a cosine of x dx. Wow. We can do that one next time, maybe. When I have a little bit more triple integration by parts. Okay, cool.
The parts wouldn't get there.
Wouldn't work. We'd have to maybe like a Feynman trick. Feynman trick, maybe.
You start with the Feynman trick. And
we love the Feynman trick.
Do a Weierstrass substitution.
Yeah, I've heard that word Weierstrass before. I need to like know more about what it is, but
it's like if you have a function of trig functions, right? So cosine and sine. It's a tangent half angle substitution that lets you turn all of your sines and cosines into rational functions. So then you can integrate and then swap back to your original sines and cosines.
I see. Then you can go back and forth here. A duck, not a dick. A duck. That's what I meant to write. Anyways. Okay, cool. Let's close out the stream. Hope everyone, thank you again for coming to Actual Education Office Hours. Appreciate all the questions and stuff we had today. You guys are great. Love it. Our next stream is going to be... When is that going to be? Let's see. Probably tomorrow, I think, actually, right? Yeah. Let me go to the website. Actualofficehours.com has the schedule. Connect the one game. But yeah, if you go here, check out our streaming schedule. We will be live tomorrow, a little bit later, 5 o'clock Pacific, and then looks like Zach's gonna be doing some fun software development tomorrow morning. Go check him out for his trivia game, which we are gonna play on the 11th. We're coming up with a time for this, I think. Zach, if you're watching. But okay, cool. All right, again, thank you again. I really appreciate everyone being here. It was a fun birthday homework stream. You guys are great. Let's go raid someone. Let's go say hi to someone. Boom. Let's see. Nerduino's up. Physics Depression's up. I like Physics Depression. He's doing like some. Oh, he's doing circuits. Maybe if you guys want to ask Physics and Depression some crazy circuit questions, go say hi to them. But awesome. Okay, great. Well, enjoy the rest of your weekend. Appreciate it, Jorgen. We will see you tomorrow. Peace.
Really finicky, and so you have to balance it very carefully to get it down to 0.